You know all the stories. Hey, you remember that time Bob Sargent saved WSC? Yeah, I heard that. Remember that time he started the board of directors and created the bylaws? Yeah. Remember that time he came to Virginia Tech and he yelled at Ernie Page when he was a graduate student? Yeah, these are old stories. The countless awards and recognitions, the many highly cited VV&A papers, we all know that stuff. You look like a good audience, and you deserve better. This is a Titan talk. You need new nuggets about this man you're going to hear from. Luckily for you, Bob's daughter Tiffany happens to be with us. Tiffany provided us with some new nuggets, which I will share with you now. Tiffany writes, most people Bob's age spend their winter in Florida, but Bob is a ski bum in Park City, Utah. Bob skis his age every year, and this year that means he'll have to ski 80 days. Does anyone have a simulation for that? I think falling down is a particularly interesting stochastic process. Bob is a huge college sports fan. One of his biggest dilemmas was when his beloved alma mater, Michigan, played his employer, Syracuse, in 1998. It's too bad that Tom Brady didn't have Tom Schreiber's help in simulating better scoring plays that night because Syracuse upset the national champions. Go Orange. And lastly, while some people in this room might play tennis on their Xbox and PlayStation, Bob plays actual tennis. Still, during the summertime, regularly. In fact, he has medaled in the New York Star Senior Games.
New York Steak.
This says New York Star.
Oh, is that what it says?
Who are you going to believe, me or you? So there you go, some new nuggets about this titan of simulation that I give to you now, Professor Robert Sargent.
Thank you, Ernie, and thank you for inviting me to give this Titan talk. It's a real honor to be able to give a talk at the 50th Winter Simulation Conference. As you can see, the title of my talk is a perspective on 55 years of the evolution of scientific respect for simulation. And what does that 55-year mean? Well, I was first exposed to simulation as a first-year graduate student at the University of Michigan in the fall of 1961. Part of a course was devoted to simulation, and when I first become exposed to it, I said, boy, this is for me. I loved it. It matched my capabilities, and so I proceeded to spend at least 55 years. What I'll be talking today is about some of my involvement, perspective, and observation regarding this 55 years. So what I'd like to do next is find out when you guys were first involved with simulation. So we're going to show by your hands the decade that you first became involved with simulation. So everybody who become involved with simulation for the first time, and by simulation we mean discrete event simulation, in the 1950s, please raise your hand. Nobody. Well, that's not surprising because I thought that would be the situation, that nobody would be involved in the 1950s. So all those in the 50s, keep your hand up. Not me. So everybody first become involved in the 1960s, please raise your hand. I know a few people out there. Wow, a few more than I would have guessed. All right, so maybe we had 20 people or so. Keep your hands up. How many people first became involved in the 70s? Put your hand up. Wow, a few more. Keep your hands up. 1980s, put your hands up. Wow, maybe we got 30%. You know what? What I'm going to be talking about is what you lived. You could live through what I talked about. How about 1990s? Wow, they really shot up now. Okay, now the people that came in the 1990s, you may have experienced some what I was talking about, but some of it may be history. Let's put our hands down. All those who become involved with simulation in 2000 or later, please raise your hands. Wow, looks like we got about about 48%. 2% of you didn't raise your hands. What the hell are you here for? To join Las Vegas or what? All right, so those people who put their hands up in the latter group, what I'm going to talk to you is about history. So some of you is going to enjoy what you lived through, and somebody's going to have a little bit of history. So let us proceed here and see what simulation people had to say in the very early days. In the 1950s, in a paper in 1958, Harling said, "It has often been said that simulation is last resort," a negative comment about our field. How about the 1960s? When all else fails, in capital letters, is simulation method last resort? That's what Harvey Wagner wrote in his famous book that people use. That's what people was taught from, Principles of Operation Research. Harvey was the dean at University of North Carolina. And so remember this remark, because we're going to come back to it. He was very negative about that. He did give a keynote talk here in simulation one year in the 70s. Let's look what this guy, Lee Shrubin, said about simulation in 1987. He was chair of the Timms College of Simulation Gaming, and he wrote in the newsletter, "Simulation carries with it the image of unsophisticated brute force problem solving with ad hoc what-if experimentation. Simulation is frequently referred to as a method of last resort." So what are we seeing? Some more negative comments about simulation. And in fact, from the 1950s through the 1980s, simulation lacks scientific respect, in my judgment. Let's jump ahead to the right side of thing that's green. It says simulation has considerable respect. That goes on today. So how did this change occur? Well, it came through the evolution of simulation. And that's what we're going to be talking about today. That's the subject of my talk, is a change from the lack of scientific respect for simulation to simulation having considered respect. So how about a little bit about myself before we proceed on, because that's my perspective. I learned about simulation, as I said, my first year as a graduate student at the University of Michigan, where I got my master's and PhD. We looked at simulation in those days. Simulation was taught through lectures. There was no textbooks in simulation. No how to do simulation materials. No simulation languages. The very few universities, and there weren't many, that even taught discrete event simulation in that days. And what do? We programmed in a language called MAD. MAD stood for Machine Algorithm Decoder. It was similar to the Fortran language, and it had no support functions. It said a very crude random number generator, which most scientific language had was a crude random number generator. And so when we wrote something, we had to write everything, all the support functions, event list, random variable generation, and so forth. And we used an early computer. In Michigan, we had an IBM 709, and you see a picture of a 709 there. And that's only part of it, because it took big machines with lots of room, lots of space. And so I got my PhD there in '66, and then what happened? I joined the faculty of Syracuse University. Why did I go to Syracuse University? They were starting a brand new interdisciplinary program called Systems and Information Science that was supported by IBM. Or they give money to develop a master's PhD program in that area. It turned out that was about my plans, but I spent my entire career at Syracuse involved with simulation and so forth. And what I didn't know, I went to Syracuse, they had a working relationship, the College of Engineering, with the Rollmare Development Center, which is part of the U.S. Air Force, and I immediately started working in research with them and worked on computer-based models, including simulation, during my time there. And of course, over my career here, I contributed professionally both scholarly research and service work. And I'm enjoying what I'm doing here this week, although it's been a lot of work, is the history of simulation. I've been forced to hold mobile capacities for professional societies, and so a couple fun facts is up there. I first came to WSC in 1971. That was my first one. This is my 44th one. I'm never going to catch this guy called Tom Schreiber, this is his 49th one. He's 5 ahead of me. I think I'm number 2 probably in the number of attendees, but somebody attended. But if anybody's got in between 44 and 49, let me know. So let's look a little farther back here about the scientific respect. Simulation evolution has been continuous since simulation started in the 1950s. That's when the first major work started in simulation. Scientific respect for simulation, in my opinion, changed from negative to positive over the time period of the 1960s to 1990s, and we'll return back to that later in the talk. And what's forcing this evolution of simulation is the modeling of complex systems. There's no other tools available for studying and evaluating, designing, and so forth, analyzing complex systems. And so that's been the driving force of evolution. Evolution has occurred naturally. For simulation, it's a new scientific field. Simulation was started new in 50, in my judgment. It's pretty much occurred naturally. There has been no driving force of somebody coming in and give a big bucket of money to say, go do this or do that. And in my judgment, there's been numerous evolutionary processes involved in this, and there's so many that we can't go through time slice-wise. What we're going to do is talk about processes over time. I'm going to group the evolutionary process in the group, and we're going to talk about them over time. Now, I believe there's two aspects of this scientific respect. One part is what I'm referring to as change through technical evolution, namely that in the early days, simulation was known as a brute force programming effort, and that was correct. But any computer programming effort was a major effort, and simulation known as method of last resort, and I give you some statements to justify that. And simulation, in my classification, gone through a technical evolution to become a method of choice, SUS method of choice. The other aspect of scholarly respect, I believe, has got to do with the lack of, the other scientific respect is scholar respect. And I think the lack of it has changed to what I'm calling perception evolution to obtain scholar respect. We're going to discuss each of these separately. So we're going to discuss this one first, and then we'll discuss the other aspect after I finish this discussion. So what was simulation like in the early days? Well, we used early computers, ad hoc methods, in scientific language like MAT or Fortran, or in the later 60s and 70s, simulation programming languages came along and they were used. So we'll discuss each of these separately. So what was the computer technology like in the very early days? Well, as already indicated by the 709, they're physically large machines. We take this corner, at least of this room here, to put those early computers in it. And today we carry it around much more powerful in our hands. Operating systems use sequential processing, also known as batch processing. And the input was in punch cards. Some of you may not know what punch cards are, but you see pictures of them there. That's what we had to do. A card for every line of code, a column for every character. And if you punched a couple hundred cards, you're bound to make one or two typing errors, and you had to redo it. Machines had little main memory. Computation slow by today's standards. Submitted a job into the computer center or computer department, you got your job back in a day or two. And it took several days to obtain a computer program that run correctly, and several, maybe large number of days. So let's talk a little bit about simulation methodology and simulation software. And I've covered this a little bit briefly, but I'll be more precise here. Simulation program is written in a language available, such as Fortran. In the early days, we had to write all the support functions already indicated, event list and random variable data collection, data analysis, whatever you wanted to do. And then the simulation languages became available in the late 60s, early 70s. These were the earlier simulation languages. And ad hoc method was used for writing your computer programs and doing your modeling and analysis and so forth. Took a considerable amount of time to obtain a correctly running program, and this extended through the 1970s. Ad hoc methods were used for analysis of simulation programs. How do we do design of experiments or whatever else we were trying to use? But usually it was little time to do that, so that wasn't too much of a major problem, because time you got your computer programming running, it was almost too late for your study. It took a lot of time. So let's look at a comment about that last one. In a famous paper by Nail and Finger on validation, if you want to hear about the history of V&V, come to my talk this afternoon in the last session in the history track talking about the history of V&V. And this paper by Dale and Finger is one of the very early ones, a very well cited paper. And in those days, in the important papers, they often had comments. And this is published in Management Science, and these are comments from two well-known management scientists in those days said, the problems of building complex simulation models and getting them to operate on computers have consumed so much time and energy that the validation problem has been neglected. Not only the validation problem, but much analysis, just no time left. So let's look a little bit about the driving force that was going on regarding simulation. There's two types of people that was doing the evolutionary work in the very early days. That was a set of people whose one used simulation to solve problems, and the other set we'll get to that was really developing scientific basic methods because that's what they wanted to do. So let's talk about three of these people who were developing. One was Dick Conway at Cornell, and when I interviewed him for the video for the Simulation Archives, I said, Dick, you had all the ingredients in your work that you're working on for a simulation language. Why didn't you develop one? Dick's response was, I wasn't interested in developing simulation. I had to develop simulation so I could work on my scheduling problems. That's what I wanted to do, solve scheduling problems. So he was not interested in really developing simulation. He was doing it so he could have a tool to use. Now, if we talk about Julian Reitman, Julian Reitman was an entirely different kind of person. Julian was the one that forced IBM to release GPSS initially. And he was interested in having tools not only for him to solve these problems, but for people that work with him. And also, some of you know that Julian Reitman developed a Norton GPSS. And Julian was working on like airline scheduling problems, and military systems, and so forth. He was looking at large-scale systems. As some of you may know, in the very early days of simulation, there was two countries that was developing simulation. One was the United States, and the other was England. And England is where K.D. Tucker was. He wrote the first book in discrete event simulation in 1963, although I heard debate in the history session, maybe it was 64 to come out. I don't know what was true. But he worked for the British Steel Company. He was the one that derived much of the stuff in England for simulation language there, a worldview, and wheel charts and that kind of stuff. And he worked for British Steel, and he was interested in solving steel problems. So these are three of the people that, primary people that was driving the early days of simulation. Let's look at those who may develop science-based methods for simulation. George Fishman. He went to work for RAND Corporation, and he got his PhD while I was there at UCLA. And he had come from the background of economics of MIT and I believe Stanford before he went to UCLA. And he did output analysis. Everybody knows George Fishman's book and his output analysis, I'm sure. Another guy, Phil Kvyat, he got his bachelor's and master's at Cornell University, and then he went to work for US Steel and was working on modeling things. Then he went to RAND Corporation and worked on modeling and simulation. He worked with both George Fishman and the next guy I'm going to talk about, Harry Markowitz, and developing things. And before he went off, Phil Kvyat went off, formed the company eventually. And then, of course, there's Harry Markowitz. And most of us probably know Harry Markowitz. He's got the Nobel Prize for economics, PhD dissertation, but his primary interest was in simulation. And he developed a SynScript simulation language and co-founded the company CACI, which did simulations. Using SynScript, of course. Okay, so there's other individuals who develop scientific methods, and look at the set of papers in the history of simulation track. We've been going through those today on simulation methodology, and this morning we had two sessions. We got two sessions this afternoon on that, including one right after lunch here, where we're going to have all the authors of the algorithms for a parallel discrete event simulation. So if you're interested in parallel discrete simulation, you may want to go to that session right after lunch. Okay, so we discussed the early days, so let's talk a little bit more about technological evolution. We've been discussing it, so I'm going to break these kind of processes into three groups. computer technology, simulation methodology, and simulation software. So the computer technology developments, as we all know, that's been a field that's tremendously evolved over the years, probably more so than any other technology field. Computers, as we know, has tremendous cost reduction occurred over the years from 1950s to today. Physical size reduction, increased processing speed, increased main memory size, software improvements, graphical capabilities, ease of use, and so forth. If we just look at the single type computers, in the 1950s we had a mainframe with batch computing, which I showed you with card input, and then we moved to interactive computers, where you sat at a desk and had a terminal connected to a machine in another room, a large machine, but then you didn't have to do cards, and then you got your computer back pretty quick. You didn't have to wait 1 or 2 days. Then we moved to desktop computers, kept the device on our table or work desk, and then we had graphics added to it. Today we have laptop computers. Everybody's got their laptops out here using them, and one up here, okay? And of course, I'm not going to get into it due to time, but we also got networks of computers and parallel computers and so forth going on. Tremendous change. So what else happened? Well, floating point operation increased trillionfold from the 1950s to today, and memory size per unit cost has had the same kind of transformation. What about simulation methodology developments? How have they changed? Well, there's been significant change. We went from ad hoc methods to science-based methods. And that's what's coming in the history of simulation track today, and I'm going to go through the details of them. Some of them things, areas like random variable generation is pretty much matured. Other areas like optimization is still rapidly developing, but they all have science-based methods. So there's been a complete change in the methodology of simulation from total ad hoc to total science-based methods. What about software developments in simulation software? Tremendous changes have occurred in simulation software through evolution. And this has only become possible because of computer technology evolution I went through a couple slides ago. In the early 1950s, we started out using science-based language like Fortran. We moved to early scientific simulation programming languages. That had some support functions, one worldview. They weren't computationally very efficient. Then we moved to more advanced simulation programming language. They worked at interactive computers. They were compiler-oriented, computationally more efficient. And then graphics came along, and graphics become an add-on. They weren't integrated. They became like animation. They had software programs to do different aspects. And what do we have today? We got an integrated system, a simulation software system that has the capability to build the models, execute the models, and run analysis, such as design, experiment, optimization. It's all included in our software system. We have integrated software systems. So we moved from having basically only a scientific language to nice integrated systems. And today, the simulation software systems provide a cost-effective environment to perform simulation studies. So, what have we covered? We covered the early simulation. We've gone through the technology evolution resulting in the use of simulation of modern-day computers, science-based methods, and simulation software system, which makes simulation method of choice and simulation having considerable scientific respect for this aspect of simulation. Let's look at the other aspect. Lack of scholarly respect. We went through what I'm calling perception evolution to obtain scholarly respect. So let's look at the early days here. I claim from the 1960s to 1970s, there was a lack of scholarly respect with respect to the field of simulation itself and to individuals working in simulation. Let's look at that in a little more detail. Who held this negative image? In my judgment, it's the people that was more scholarly and academic oriented. They look down their nose at you and say, you gotta go simulate to solve that problem? Aren't you smart enough to do it some other way? Can't you use some mathematics to do it? I mean, that was sort of the attitude that was going on then. And who were these individuals? These are people working mainly in the fields of operations research, management science, industrial and system engineering. And these people did not work in simulation, and most had no idea what simulation was involved with simulation. Relative to other fields, computer science had a less negative view. The reason I believe is because they knew what it took to solve problems on this computer, what it took to program and solve things like, or put a payroll system up or something. And who held a positive view? It was the two set of individuals I talked about earlier. Those who were working on developing simulations to solve problems, individuals working on developing problems. So, that discussed early days. So let's talk about perception evolution. I divided these into three groups. The first group, communication and technology advances. Now that could have been put in either group, but I put it with a perception evolution because that's where I think it had the most major effect. We also got contributions of other entities, and I'll be going through those, and the contribution of simulation in other fields. So let's look at the communication technology advances. There's been, over the years, starting from the 50s, there's been many conferences and workshops on simulations. Some of these were one of a kind, very early days. Might have been on simulation languages, or today it may be on a workshop on a specific type of aspect of simulation. Others ran few of a kind. I think there's 4 or 5 years there was supposed to be on simulation and computer systems. I remember the annual simulation conference that IRK run maybe for a dozen years and so forth. And occasionally there's one very long-lasting one. We're at one today, 50 years old, which I'll come back to. These early conferences produced books. I remember Bernie Ziegler and two of his colleagues, they run a conference about every 3 years for 4 years in a row, come out with books with white covers on. There's special proceedings for a lot of these conferences. There's special issue journals. I remember Dick Nance, somebody else had a workshop where we produced an issue for the 1981, one of the 1981 Operation Research journals. All these things were very important in the evolution of simulation that helped develop scientific respect and scholarly respect. Okay, and I want to come to something very unique. WSC. We're all here at the 50th WSC. I think you can look across all different kinds of professional areas, and I think you won't find anything else like WSC. We have many sponsors. We're run by volunteers. It's a premier conference in our field. We're 50 years old, continues to evolve over time, and underlying in case we have financial issues is the WSC Foundation. Okay, so this is one of the areas that how technology advances have been developed are communicated to the world, to our own profession and to others. Books. Many books started to become published in the late 60s, 70s, 80s. As I said earlier, there was no simulation materials in the 60s, basically, and all of a sudden, every faculty member wanted to write one. Everybody who wrote an application wanted to write a book, and they did. We had lots of books. That was good, but what happens with technology improves, these books become obsolete, right? And you can't use them for textbooks or communication, so there were more books developed later, but there's much fewer books in the 1980s. Tom Schreiber in his 1992 WSC 25th anniversary paper gave a breakdown of all the books and most of the listings of the books, but not all, for the books that have been published up through 1992 in simulation. And there's one special book that I just believe that needs attention, and that was Bernie Ziegler. He's got, I think, 3 or 4 books now. But his first book, his 76th book, contained a theory for simulation based on general system theory. And he had written some articles prior to that, journal articles. But that book, I think, really showed that our field had underlying pinnings and help give scholar respect. And books, of course, over time show the technology evolution that has occurred. Let's come to a third topic, journals. Journals are a little more controversial. There's different views and opinions of journals. Journals, in terms of scholar respect, when they started being published in high-quality journals, we had high-quality publication, people respected that. But another major effect occurred was when the simulation department started being established in journals in the late 1970s and 1980s at the push of the people working in simulation. And so this evolution really helped attain scholar respect for simulation. And of course, as an example, the communication of ACM, which I was first department editor of for simulation, eventually they took research publications out, and under leadership of Dick Nance, we developed Tomax. And there's simulation journals, so there's journals that focus on purely on simulation today. But I think evolution is still needed. In the early days, it was very difficult to get any journal to publish simulation because there wasn't any respect. But a lot of that's been removed, but there's still some journals that's not easy to get simulation published in. And we find in some of the journals, both by the editor-in-chief and even department editors for simulation, is biased against some specific topics, simulation topics. And every time there's a change of editors, you get rid of some bias and get some new biases. And we find that some editors don't have a really sufficient knowledge of editors, my judgment. And it's still difficult to publish some areas. In particular, one area is modeling. I remember talking more than one occasion with the late Alan Pritzker about publishing modeling. And Alan says, I no longer try to publish my modeling ideas. I publish the Winter Simulation Conference. That's where I publish my modeling ideas. And I think that's still true today. We can publish modeling ideas in WSC, which is a great outlet, but it's not easy to publish modeling ideas in papers, in journals. So let's look at the second thing I put down for getting scholar respect for simulation. Contribution of other entities, professional societies. I think the sponsorship of professional societies at a conference like Winter Simulation really helps. Societies give things like simulation awards, and I'll comment on those later. They work to get the simulation departments in journals. What was called the Timms College of Simulation and Gaming, now ISIM, work to get simulation into in the management science, for example. It's because of these that worked at it. Many of the societies have associations with one or more publications regarding simulation. And we'll, at our meetings this evening here, we'll have SIGSIM and ISIM, and they'll talk about the reports from different journals and so forth. There's awards for simulation that helps attain scholar respect because individual get them, receives them, and then they get publicized, and people say, wow, look what those people have done. ISIM gives the best simulation publication award, which was originally for papers in management science, and it was made open to all publications. That was the first award they established. Then they established the Distinguished Service Award, and then the Lifetime Professional Achievement Award, which is the signature award. Now, I claim that ISIM, in developing these awards, were one of the first societies to develop awards across many professions. You look at Informs, what's Informs today. We look at operation research and management science, all the different professional areas like optimization and other areas. We had our awards first. And so I think that showed that we had some kind of leadership kind of capabilities. And of course, SIGSIM gives the Distinguished Contributions Award as one that's for contributions. Let's look at something that most people don't think of in terms of getting scholar respect. And that's what I refer to as the non-simulation eminent scholars. That means as people become eminent in some areas, not simulation, but because of their contributions in some way, it's obtained scholar respect in simulation. And one of the first ones I want to mention is Bob Befhofer, who was at Cornell, was the father of ranking selecting methods. Now, how did Bob have an effect? Well, first he taught people. We recognize it as Conway first brought this field to simulation. Where did Conway learn about that? He learned about that as a graduate student. About that, and so they brought it to the field. That's how it came about. And of course, I was general chair in 1977 WSC. I asked Bob Befhofer to come and present a paper, so we had a session on ranking and selection, and Bob came and give a paper at that time. But let's a couple more people that Bob Befhofer turned out. I saw one of the names go up today, Ed Dudowitz, who's now deceased. He did papers here at the WSC and wrote papers on ranking selection. He did his PhD under Bob Befhofer at Cornell, and then did work there. And of course, we have our friendly Dave Goldsman here. He does a lot of ranking selection methods. He learned in his written papers with the late Bob Befhofer. And so this is a scholar who's well known in another field that wasn't directly contributed to it, but he did that through classes and teaching students. How about another such individual, Donald Knuth? We know Donald Knuth, probably most of you do, because he wrote a series of books called Art of Computer Programming. And if we look back at the 1969 Volume 2, Chapter 3, he had 2 chapters in each volume. Chapter 3 was on random number generations. And that was the state of the art. He wrote the state of the art of random number generators and developed special tests and so forth there. Another thing he did in the mid-1960s, he developed this language called simulation-oriented language. It was for Burroughs computers, so it didn't get out. But I remember reading an article of Jim Hendrickson once, and he said that the SOL had some very unique and interesting ways of doing things. And when Jim Hendrickson says that, I listen. Okay. Another person, Donald Eigelhart, Stanford, become well known for his stochastic process area, and then he later moved into doing research and simulation. He turned out a large number of students. 11 of those PhD students wrote and produced simulation articles. 3 of those students received, or former students, graduate students, after they got their PhDs in the professional world, received the Best Simulation Publication Award. Most of those people went on and developed some very interesting things. So these are 3 people in different dimensions that made contributions, I think, to increase scholarly respect. And of course, there's a computer simulation archives at North Carolina State University libraries, which collects, historical material, and they have documents from 1950s present. And of course, what really added prestige, I think, too, and recently is the 25 oral history videos that's been added, including Harry Markowitz. How many fields do you think about that have an archive? We don't see one for optimization. We don't see one for some of the other topics, but we have one. It's important. Very respectful. I think it brings scholarly respect. How about contribution to simulation in other fields? We look at the first prominent 3 simulation languages. We'll see that they made contributions in computer science. GPSS brought the process concept. Simula brought object-oriented programming, and we know that's a common approach that's used in computer programming today. And SimScript brought entity attribute set concept, which is often used in database languages. How about contributions to statistics? Tremendous we have. Output processes looked at correlative processes, ranking selection, new experimental design. Experimental designs were originally developed for the physical world, and they have constraints on the number of factors that can vary or the range over factors that can vary. On simulation, we can do any damn crazy thing we can think of. And so we have to have new designs, et cetera. I'm not going to talk about any more, but they're there. How about contribution to other fields? Well, I think we have a guy in our field that's developed random number generators that's commonly used almost everywhere, his software and his methods. And of course, random variable generations are used in many fields that they come from simulation. So where does that take us? Well, we've discussed the lack of scholarly respect to evolution, what I recall in perception observation, which is accomplished that from 1980s on to today, we have scholarly respect. Okay. And so where does this leave? We summarize this, that we see that the 2 major aspects, or the 2 aspects of lack of scientific respect occurs, we now have it. So I believe that. So I believe this change occurred. So let's look at a few comments that was made to sort of support my my view and the hypothesis that this occurred, we look at 1988. Remember I mentioned Harvey Wagner in the book where he was very critical? Well, in 1988, he gave a special talk, and then that talk was published in the journal Operations Research. And he said, simulation reduces the risk of adapting unworkable approaches. It usually exceeds math program factor by 10 to 1. He also said it was resource intensive. But Harvey Wagner moved from being very negative to becoming warm to the subject matter. 2012 at the WSC, Lucas and others wrote, and I rephrased it to put it down in one sentence, simulation use has grown exponentially, whereas linear programming optimization are growing far more slowly. They had data based on publications in that article, and you can go look at 2012. Let's look at something a little more recently, 2015, written by Lucas, the two Sanchez's that are here, Dave Kelton and another two authors maybe. He said, simulation done properly should often be the method of choice. So what is Bob Sargent's view of how this has changed over time? Okay, so I'm going to give it to by decade. 1950s, I say it was negative. I say it become more negative in the 60s, shown by the double negative. 1970s, I believe it was more negative, stayed there. 1980s, I think it started becoming less negative. 1990s, I believe the scientific respect for simulation changed from negative to positive. I believe in 2000 it changed positive. I think in the 2010s, the scientific respect has increased, tremendously increased, and it's that. So I think if you look at my paper and the quotes I have there and here, you find it supports my view, and you find I don't know anything that contradicts it. So what about the future? I think simulation has a bright future. Today, simulation has considerable scientific respect, and this respect is a result of the evolution of simulation. Repeat, today, simulation has considerable scientific respect, and this respect is the result of the evolution of simulation. Remember it, quote it. That's where we are, folks. In the future, simulation will continue to develop in many ways, including scientific respect, resulting in a bright simulation future. Prior to going on my last couple slides, I have an announcement to make. My daughter did these graphs, slides for us all to enjoy, so I wouldn't use the old-fashioned method of text. And she took and had to educate me to be like a young person instead of the old guy like I am. And she also gave me suggestions how I should talk to slides. And I'm probably about halfway where she says I should be. So let's go on to the old-fashioned way that I would do it. I'm now going to talk about myself again, because I finished my technical presentation. Today, I shared with you a few of my perspectives of simulation. I have enjoyed my 55 years of simulation. When I got exposed to simulation back in 1961, one-third of a course, I said, by God, that's what I'm going to spend my life doing, because I loved it. I did. I have made many simulation friends. I plan to move on to other ventures in my remaining life. I encourage others to make their simulation contributions. And so, it's been a hell of a ride. I hope my son stays up a little longer. I hope I have a few more years of my life to do some different things. But you see the sun's coming down. And as Ernie said, being 80 years old, I'm fortunate to be up here yet. And so, folks, thank you. I hope I stir some questions to challenge me. Any questions? No questions of Spike here. Some Mike's here. I was hoping somebody would challenge me, but here comes the future guy, the 50-year guy. You going to live 50 more years, Barry?
No, I don't think so. So, Bob, one of the other areas where you've contributed a lot is to hybrid modeling. modeling that goes between simulation and analytical models that
I'm
combines.
sorry, I'm having trouble hearing you. No, well, you can come up here, I'll repeat.
Hybrid modeling. I was going to ask you to say a little bit about that because you've been a pioneer in thinking about models in between simulation and analytical.
Okay, Barry wants me to make a few comments on hybrid modeling since I've been there. Okay, I look at modeling, and I've tried to write a paper, but journals don't like this kind of stuff. In terms of talking about a little bit about history, I look at the separation of modeling should be separate from the solution of models. Okay, and the hybrid models, you combine different modeling views, and then you can look at the solutions to models. And I think there's a whole future that's going on there. We see that going on, and if you go back 50 years ago, there's a paper on combined simulation that combined discrete event and continuous. And one example they had was a discrete event in what's called industrial dynamics and the system dynamics today. And yet you see our thing calls it hybrid simulation in the last 3 or 4 times. The wheel's being reinvented in many areas, okay? Now, Barry specifically was mentioned the combination of analytical modeling and simulation modeling. I think that's coming. With the computer we have today, people can do that. It takes a more sophisticated model to do it, and there has been. We got agent-based modeling and so forth. As we move to more complex systems that we model different hierarchies, one may be strategic plan and the other is operations, and we want to bring in a human decision maker. I don't think we have a good understanding yet of what's the best modeling worldviews to use for certain kinds of applications or different levels of operation. I look at the healthcare system, and there's going to be a paper in the history track the last day on healthcare systems, for example, and they are mixing system dynamics and discrete event simulation, looking at different hierarchy or different kind of operational levels. And so I think there's work to be done on how does all that break out in terms of what's the best kind of worldview, whether it's agent-based or some other kind of languages, modeling worldviews to modeling certain aspects of the world. I think there's work to be done there. In the combined analytical work in that. There's some earlier work done that's in that paper of Shanti Kubakar and myself about modeling, and we don't see many papers like that because I don't believe it's easy to get them published and people don't get recommended, and thus it doesn't help, promotions at universities or PhD students to publish in those kinds of things. So I'm not giving a real concrete answer, but I think there's a whole opportunity, but my feeling is there's this difference between the modeling and the solution to the models, and that's what's very important. In a paper I submitted that wasn't accepted I had some, to a journal, and I had some ways of looking at trying to do some of this classification, but it's going to take steps. You look at statistical analysis, they go through a variety of kinds of confidence intervals and so forth by adding new things to it. But in the modeling, you can't do these baby steps because you can't get it published. And it comes back to, I think we can do more publishing of that kind of WSC, but some people say, well, publishing WSC doesn't help me in my promotion or anything at the university. So that ties back into the journal aspect, in my opinion. I don't know whether that helped answer you or not. Other questions? Everybody else got any different views in terms of my view of scientific respect for simulation? Ah, good. I figured there'd be a few I could drag out.
Okay, so you said early on that CS was one of the few fields that actually viewed simulation more positively, and then now we've gotten all the respect from OR, IE departments. What's your view on CS departments now? My perception, which may be incorrect, is CS doesn't view simulation nearly as positively as, say, OR and IE departments at this point.
You're going to have to come up. I have trouble.
Oh.
My hearing's not the best, I guess. Just come up here and tell me, and then I'll repeat, please. I'll make everybody show off. No, who's not doesn't have respect? Yeah, go ahead.
No, I mean, at the beginning you said CS departments gave us more respect than everyone else.
More than compared to the OR, yeah.
Right, but now it seems to me like it's almost reversed. Is that true, or is my perception?
Okay, thank you. Okay, his question is that I said earlier that computer science people had less negative respect than the ORMS ISC people. And he feels it's the reverse today, if I understood that. And he wants to know whether that's my view. I'm sorry, I cannot answer that question because I do not know what the computer science people are. The people I know in computer science don't have that problem, but I have such a small sample, I cannot reply to that. You know, I haven't taught in a few years, but performance evaluation of computer system stuff, I haven't found that negative, but I can't say in general. Dr. Nance wants to come up and probably answer the question.
No, I will just present my perspective, and that you are, Michael is correct in the disappearance of the topic simulation in the curricula for undergraduate computer science. I think was a bad mistake. It was made by a committee, and I don't think it is so much a lack of respect, though. I think it is a view of simulation among the prominent computer science education community is it's like oxygen. It comes for free. You don't emphasize simulation because it's used in so many areas within computer science. And it shouldn't, like oxygen, I guess, be compartmentalized to one particular part of the discipline. That's my.
Well, you see in business schools, they've, in last several years, simulation is not taught as a specific course like it used to be. So, in that sense, simulation I don't think is being taught as readily. I think it's being incorporated in other fields, and people can go do it. That's part of the problem, I think, is that people don't have a solid education of the methodology needed to do simulation. But I don't have concrete evidence or enough knowledge to comment on that. Other questions before we get cut off? I guess I kept you all asleep. Anyway, thank you, people.
Walk this way. All right, say it with me one more time. Bob Sargent. Here he is, ladies and gentlemen, our Titan.
Oh, thank you. I didn't know what you were doing.
You can come back in 50 years and give another one. Enjoy the rest of your day, folks.